Okay, so Sid, what I'm going to do here is we're going to look at some ideas to build our way back up to Gauss's law. And the thing that I really want to kind of start with is the idea that we have some source of something. And instead of looking at electricity and magnetism, I'm going to think in terms of gravity. And so that we have some point source that's generating a gravitational field. There is something that's pulling towards this. And so we have field lines. I'm going to change color for my field line. I'll make my field line green. That come towards this. I'll try to make relatively equal amount of field lines, and I'll give them direction arrows in a second. And so I have my gravitational source. All right. And we have field lines that if I had another mass, it would feel an attraction towards my source. Right, and so vectors, and we have a direction field of the vectors, and it's all due to this gravitational source. Well, one of the things that comes out of having a point source is certain geometries, and we're going to work this geometry towards an understanding of what we're looking at with Gauss's laws and other ideas. And so anything that has a point source in 3D space and creates a field around it, or light that illuminates around it, that source has some initial intensity. There's something that measures the strength of that source. And as we get further away, that strength spreads out in equidistances. And so anything you see geometrically that does this, we can think of as we get further, and this is usually a little hard for me here, but let me see if I can do it here. Yeah. And if I get some radius away from the point source, right, that the number of field lines passing through it are spaced out further. Let me do another one here. I'm going to change color here. Try to do this in a yellow. See if the yellow shows up. And so the space between field lines is slightly larger the further out I go. And so the strength of the field weakens as we go away. And this actually geometrically sets up the inverse square rule. If we're thinking in three-dimensional space, these shells are spheres. And so we have some source in the middle, and if the source has some energy that is divided out as we get further and further away, that energy, this source spreads equally over the surface area. And as I get further away, the surface area increases. And surface area is increased by r squared. And so when we talk about gravity, we said, hey, the force is equal to some constant times mass 1 over mass 2 over r squared. There's this weakening of the strength of the thing as we get further and further away, right? And our gravitational fields, right? Well, we think about, right, some gravitational field that's defined by one mass, the source mass, right, versus what's coming through. And so this idea that a source has a concentration of what generates the field. And you could think as we get towards the point source itself, that field is infinitely dense. And as we go away, the density drops down. And so the field lines that get generated by a point source move through imaginary spaces. And so what I want you to kind of focus on here is this idea that we have the number of field lines coming in and out. But notice I have one source. I've got 1, 2, 3, 4, 5, 6, 8 field lines. 8 field lines cross every single one of these spheres. Right? In fact, any shape I put in that surrounds the source, let me put one in orange. Let's see if I can do an arbitrarily weird shape. If I look at the surface of this shape, 8 lines are coming in. And so something about a surface enclosing a source relates back to the amount of field lines coming in. And this is the nature of what Gauss was observing, is that we have some source, then if we can enclose the source in a surface, we will be able to infer things about the field related to that's being generated by it. And so Gauss's law is a way of trying to take the geometry of surrounding it. And it's a topological argument. I can deform this orange surface by pushing it and bending it into a circle. And so topologically, that closed surface is the same as those circles. And so what Gauss's law says is, hey, I know something about what's passing through a surface, right? Because it might be easier to measure things at a surface. Then I should be able to infer about all the sources inside the surface. All right. And so that's the first thing I want you to think about here. Look at that, and we'll go from there.